Hello, Algebra 1 students. Today we're going to focus, yesterday you had your assessment on graphing, and now we're just really going to go backwards and write the equation. So we gave you an equation, you created a graph, and now we're going to give you a graph or a table, and you create the equation. So the first thing I want to do is give you these three graphs, f of x, g of x, and h of x, and you can pause the video, do whatever you need to do, but I want you just to create a sketch, a graph of each individual one. So if I were to graph f of x, what would that look like? If I graphed g of x, what would that look like? And then h of x. Let's just take a moment and try that. Okay, so I'm going to graph each individual one just using the points. So if I look at f of x, we would have 0, 2, which remember that is considered our y-intercept. 1, 8, 2, 14, 3, 20, 4, 26, and then 532. So if I were to connect this, it really shouldn't look like an exponential function. It should look more like a linear that we dealt with first semester and that you dealt with throughout middle school. Okay, so that's what that graph would look like. If I look at g of x, I would have negative 1 and 2/3. Oops. Spin a little bit. Negative 1 and 2/3. Boom. 0, 2, so noticing the same y-intercept. 1, 6, 2, 18, 3, 54, holy cow, and then 4 and 162. So that's really increasing. So that if I connect it, and I'm going to write in the table, so I'm going to ignore these last 2 points, but we have the general shape, and we know that that is a growth because it's growing away from the x-axis, or in this case, that axis is, asymptote. And then if I look at that final h of x, we have negative 2 and 18, negative 1 and 6, 0 and 2, so still the same y-intercept, 1 and 2/3, 2 and 2/9, and then 3 and 2/27, so it's barely above 0. So if I were to connect that, it appears to have a shape of an exponential decay because that distance from the function to its horizontal asymptote is decreasing. And from graphing, we know that that horizontal asymptote in our course is just going to be that y equals 0. It's not always y equals 0. Once you get to Algebra 2, you'll learn about your vertical shifts, and those still happen with every function we have. We just are exposing you to exponentials, so we don't get into the nitty gritty. So just making a little note that that is a decay. Okay. So now we want to make sure, even though it appears to be a decay and a growth, and our f of x looks like a line, we want to make sure that it actually is a line. So there we're going to look at our patterns of our tables. So back in first semester, we talked about how lines always have slopes. And since I have a slope, that means my change of y, my change of x, that ratio needs to stay consistent. So 2 to 8 is 6, 8 to 14 is also 6, 14 to 20, 20 to 26, and 26 to 32. So when I take that change of y over change of x, I'll always get 6. So I know this is linear with a positive slope. Be careful because that can't be called a growth. It just has a positive slope. So I know it's linear. Now I want to make sure that this one is exponential. So back when we graphed exponentials, we know that each time you're multiplying by the exact same number. Sorry, forgot that one too. So this is each time going up by 1, by 1. So we've got that consistency there. And then what I'm trying to find is there a number that if I multiply 2/3 by it, I get 2, 2 by that number, I get 6, 6 times that number is 18, 18 times that number is 54, and then 54 times that number is 162. And I want to show you two strategies that you can use. That number is going to be your base, so I'm going to abbreviate it as base. I'm going to put a little multiplication sign because exponentials will always have what you're multiplying by. Okay. And then I can technically choose any two consecutive numbers I'd like. So I'm going to use 6 and 18. So some of us will feel really confident with just looking at that and saying 6 times what number is 18? We know the answer is 3. But some of them are going to be a little more challenging, and I want to give you another structure to use. So another thing we can say is 6 times what, so b, the base, equals 18. And then we're just back in pre-algebra land, and we solve for b. And then I can confirm, since that works every time, times 3, 18 times 3 is 54, 54 times 3 is 162. I know that's my base, and now I can actually make sure it's a growth because we know growth has that b value being greater than 3. Or sorry, greater than 1, and 3 is greater than 1. Okay, so now let's confirm that same thing with our h of x. So my x values are always going up by 1 so that we're safe there. And now we're trying to figure out times what number. So be really careful because with exponential functions, it is never addition. It is always multiplication. Because if we think about an exponent represents how many times is a number being multiplied by itself. Always multiplication. So again, some of us will feel really confident just looking and knowing what we're multiplying by. Some of us won't, and that's okay. This time I'm going to use 6 and 2 to demonstrate the other method. So I know 6 times some number has to be 2. So I'm going to divide both sides by 6, and my base is 1/3. And then I can check 2 times a third is 2/3, 2/3 times a third is 2/9, and then times 1/3 is 2/27. And then since that value is smaller than 1, I can confirm that in fact it was a decay. Now, one of the things I'm always going to suggest to you if you have a table and you're trying to write an equation, always sketch a graph like you did for your warm-up. That way, if you were to solve h of x and you thought the base was 1/3, was 3, you know you're incorrect because your graph shows you that it should be a decay, which means that base needs to be smaller than 1. Okay. So finding the base, honestly, is the most challenging part of writing your equation. So we're going to write an exponential equation to represent the exponential functions from the warm-up. So the only ones we can actually do, well, we can write linears. We did that all first semester. We're going to see how to write g of x, and we're going to write h of x. Okay. So if I'm writing g of x, I know that my structure based off of our graphing, write a little note that this is g of x, was always y equals a times b to the x. Then we just talked about how to find our base values. So our base value in g of x was 3. So really the base is really just what number are you multiplying by each time for your y values. So I'm going to take that 3 and substitute it in. Now if you remember back in quadratic land, whenever we had to find our a value, we substituted in another point. So I'm going to do that exact same thing. I can choose any point that I want. I'm going to, since I did 218 before, I'm going to use 218 again. So 2 and 18, and it'll work with any point, x, comma, y. So I'm going to put 18 in for y. I don't know what my a is, and then I have 3 squared. And then I'm just following my order of operations to solve it. So we know that 3 squared is 9, and 9 is being multiplied by a, and whenever we're multiplying by a variable, we like to put that number first. And then I divide, and a equals 2. So bibbidi bobbidi boo, we're going to put them all together. I've got g of x, which I'm using g of x not only to remind you that function notation is the thing, but also so we know exactly what table I'm talking about. I'm talking about the g of x table. G of x equals 2 times 3 to the x. Boom. Okay. And then I also want to do just a quick visual check. Is my base above 1? Because according to my picture, it was a growth. And b is greater than 1, so we are good. Okay. The other function we had was h of x. So if I look at h of x, we found that our base was 1/3. So I'm just going to substitute that in. So y equals a times b to the x, but we already found our base was 1/3. And then again, I can use any point I want. So I'm going to use 0 and 2. And one thing that we know about fractions, if we want them to become a whole number or take the reciprocal of it, we would want to use negative exponents. But really, I would look at my y values and just feel like, what are you comfortable with? Are you comfortable if you chose the point 1 2/3? If you're not, don't choose it, and that's okay. So I chose the point 0, 2. X, y. So I have 2 equals my a, I don't know yet, try to find it, 1/3 to the 0. So now if we remember from our exponent properties, anything to the power of 0, so this whole thing here, becomes the number 1. So this is just 1a. If you divide it by 1 on both sides, you just get a equals 2. And now we'll put it all together. H of x equals 2 times 1/3 to the x. And there you go.